That probably just made
That's the only one.
you could just go right now with the even though.
Yes, but I will. Fine.
Good afternoon, ladies and gentlemen. For those of you who don't know me, my name is Miss Payton. I'm the other AP Stats teacher. You should either know Miss Sayre or me, one of us two of us. You are here for our exciting in-school field trip featuring Mr. Shea. He is an actuary, so he actually uses statistics that you learn in like the real world. And with that, the floor is yours.
Yes. Can you guys? Oh, okay. Sounds like I'm on. Okay. Hey, thanks for hanging out with me for a little bit. I guess I can walk anywhere, but that's big. So, yeah, Mason Shea. I'm a healthcare actuary. There's lots of different flavors of actuary. I'm going to go through some stuff that comes out of my job that I do for my clients, and I'll talk about my clients a little bit. I'm hoping you all will eventually be intrigued enough to ask me questions. I'm also hoping that I'll be smart enough to be able to answer them. I'll leave some time at the end as well, but just wanted to kind of walk you through some of the concepts I'm going to talk about. I know for a fact from talking to your teachers that you're either covering or will be covering, and then some of the other concepts might not necessarily be on the syllabus, but could be an extension of some of the other things that we'll be talking about through the years. So, with that lovely intro, I'll get started. We're going to talk a little bit about the beginning of actuarial science. It's not that old of a profession, but there's some cool stuff there, and random variables. I'm going to take a brief detour through the Social Security system and then dive into what I do, which is healthcare, and talk about some concepts there, and then just a couple of general other thoughts I have. So, the very beginning, actually, way back in the day, if you're familiar with Halley's Comet, it's named after Edmund Halley. Well, before he was a big highfalutin astrophysicist, he published this mainstream article on mortality tables in the United Kingdom, and it generated the entire industry of annuities and life insurance. And so I want to start here because that's not something I necessarily deal with all the time, but it's a pretty mainstay thing, and it's basically that you just gather all of this data. So up here, you might be able to see, hopefully you guys can see, at each age we've got a number, and we start out with 100, that's a million, right? No, 100,000 lives. And then that's how many lives we have at age 0. And then we tick down to age 1. By the time we get to age 1, we only have 99,305 lives. Some people have passed away. That seems really simple, but this is the basis for the entire life insurance industry. So as you tick from one age to the next, it's called a survivorship table. And you can calculate by looking at the ratio of the numbers in, like, say, 8 to 7. That ratio will tell you the chance that a 7-year-old lives to be 8. Okay? Down here, we've got the chance, if you go from this row to that row, that an 83-year-old lives to be 84. Obviously, as you might expect, the chance that an 83-year-old lives to be 84 is a little bit lower than a chance that a 7-year-old lives to be 8. And you can do this in a number of different ways, by gender, by different demographic cohorts. This is the basis of life insurance, and it's one of the things I know you'll be talking about down the road, and I want to mention, which is insurance, generally, which is where you find a lot of actuaries like myself, is foundationally based on multiplying two what are called random variables, which is the chance that something happens, or the frequency, and how big the payout is if the thing happens, which is called severity. Each of these two random variables has a million ways to come up with the average, a median value, expected value. You could do it on frequency, you can do it on severity, they're different, right? So think about life insurance. This whole thing, this demographic, what's called mortality table or survivorship table, is one of the foundational ways you get at the chance that thing's going to happen. So now if I have a life insurance policy that's supposed to pay out, thank you, oh great now. If I have a life insurance policy that's supposed to pay out $250,000 at my death, that's the severity piece. Actually, let's make the numbers easier because I don't have a calculator with me. Let's say it's supposed to pay out $100,000 at my death, and there's a 2% chance that I could die this year. My life insurance carrier, if I bought this policy, should hold $2,000 for me, just in case. In reality, they're either going to need none of that or they're going to need all of it. But insurance regulators require them to hold the $2,000 because that's the expected value when you multiply the two random variables together. So that's life insurance breathed through in a nutshell. There's also some interest theory that goes on, but pretty much based on these demographic tables. And now I'll detour us over, because life insurance was the start of it, but once we started doing that and having demographic tables, a lot of countries developed pension schemes. And one of the most famous pension schemes in the United States, which you may not have heard of or know anything about, is the Social Security system. The Social Security system was designed by legislators, but implemented, executed, and maintained by actuaries. They have to not only predict how many people they're going to have to pay out to, which is actually the reverse of a life insurance if you think about it. Life insurance is about paying you out if you pass away. Pension, or Social Security, or an annuity, those are all kind of similar concepts, will pay you if you live. But I can use the same data to figure that out. So they have to figure out how likely it is I'm going to live, so they know how likely it is they're going to have to pay. The other cool thing that the Social Security people get into is, since they're accountable to the government and they want to make sure that whole system remains solvent, they also have to predict the future cohorts of people that will be eligible, because Social Security, by the way, is funded by taxes, but you have to have taxes to pay for it, and they actually have to project the cohort of future taxpayers. So not only does Social Security have mortality tables, they also have fertility tables. And they get into a lot of, this is the end of the spectrum, and the fertility tables are the beginning of the spectrum. Okay, so before I move on to healthcare, anything even vaguely intriguing, or should I just skip right on to the next thing? Any questions, comments, or even snide remarks? No, ma'am, I'm not going to take that. All right, so super simple part of healthcare. I'll go through a couple different things we do in healthcare. My job is, I don't work for an insurance company. You will find a lot of actuaries at insurance companies. I work for a consulting firm, and that means a lot of my clients are not actuaries. The vast majority of my clients are not actuaries. The vast majority of my clients haven't taken this statistics class in decades, and many of them hold your own feelings here, don't even like numbers that much. So in addition to doing all the technical work, because I work for a consulting firm, my job is then to translate that to my clients, help them understand the numbers I'm being paid to provide them in such a way that they feel comfortable using them. So it's a little extra task of me being able to not only do the math, but then explain the math to people who don't like the math necessarily. So one super simple concept that I can recall in my high school days having a little bit of an aha moment about is the difference between a symbol average and a weighted average. We use weighted averages all the time in healthcare pricing. One of the main tasks of our job is to think about how all of the past healthcare claims for a company could help us predict the future for the next year. I'm usually not trying to predict 50 years worth of healthcare claims. That's a lot harder. There are people that do that. My job is usually to say, take what happened in the last couple of years and make a best estimate for next year. My clients will set rates based on my best estimate. They will then charge their employees contributions to pay into the system based on my best estimate. So there are real downstream implications to people. If you're on your parents' health care plan, that's the type of thing I'm talking about. And we will use weighted averages all the time, because we'll think that we need at least maybe 12 months of experience from the data to project into the future, but we maybe want to use more than 12 months, and we maybe want to play around a little bit with which of those 12-month periods we feel like, and this is a little bit of the judgment part. There's some science, but there's also some judgment. Which of those 12-month periods do we feel like is the best representation of the future? So here, I actually have, I have 3 12-month periods of data. I've projected them all to the same point in the future. So I basically got 3 different versions of what next year could be. And I'm just simply saying, okay, give me 70% of that first version, 30% of that second version, and forget that third version. I don't like it very much. That's it. Now I've got my final answer. This, by the way, that might look like small numbers. That's like 800 some bucks, 200 some bucks, and $2. we do a lot of our work on a per capita basis, per employee per month. That's what this is. You can kind of think about this, back to my concept of insurance, this is kind of the severity. I'm going to later multiply by how many employees are in this company to give that client their total budget for the next year. And then, once I've done that, and we get to next year, and it's different, they're asking me a million questions about why it's up or down or sideways. So we use weighted averages in the work. The other thing we do is, this might be too small, and I apologize, we use credibility, which is another concept from statistics. Basically, if my client has a really, only like 50 people on their plan, there's never going to be enough data for me to have a credible estimate of next year's experience. It's too volatile. So we have some credibility tables that were built by my company. Every insurance company has their own flavor of these. And is there a little pointer? Ooh, yeah, okay. So this is, if you can see, this is active medical and active dental. And so one of the things you'll see is that dental insurance becomes 100% credible more quickly than medical, because dental is dental. I mean, there are people who buy dental insurance and don't even use it every year. It's really, really low cost, really low volatility. Medical's not that way. And then life insurance and LTD insurance, it's really hard to get credible experience there because it's just a completely different concept. Because in healthcare, you basically take the entire group's claims, divide by the entire people that are on the plan, and adjust that projected into the future. With life insurance and LTD, you're back to this, where you need enough people in each one of these little cells to make it worth your while, to make a credible estimate. Most employers don't have enough people in one of these cells to build their own table, so it's not going to get credible for quite a while. Comments, questions, snide remarks before I move on? Nope. Yeah.
How do you test credibility? Do you use something like a t-test or a NOVA or something like that?
You brought up t-tests? So, okay. Here's the skinny. There's no t-test in this deck. I have done a t-test recently, not for this reason. So I'll give you, we're not often tasked to statistically prove the difference, how significantly different things are. Even though in statistics, that's often a big deal. My clients aren't usually paying us to statistically prove that, plus they definitely don't want me talking about p-values. I did do some t-testing about a month or two ago. We had an internal tool that looked at healthcare quality at the individual physician level. So I've got 4,000 doctors in a city, and I've got 4,000 doctors in a different city. Each of those 4,000 doctors has a score from 0 to 100 of how good they are at their job. And the question was, which city has better doctors in terms of quality? And so, ta-da, t-test was helpful for that. So I'm glad they pulled that out. But yeah, that's actually not in here, but it is something that certain actuaries do. And in fact, when the actuaries are building some of this, they will do some t-testing, but day-to-day work, not involved. But good question. Yes? No, yeah. Yes, sorry. So what it means when you get to 100% is you can use that data to give you a credible estimate for the future. So down here, if you can't read it, it says you need to get 3,000 member life years for medical insurance before that group's fully credible. So if I have 1,500 P data to get to my 3,000, if I have 5,000 people on my plan, I'm good. I'm there. I can use 12 months if I want. I can use more or less. And for dental, which is what I was saying before, dental you only need 800 member life years. So if you've got 400 people on your dental plan, and I got 2 years of data, I'm good to go. When you get below 100, a very common thing to do is to look around for what's called an annual rate or some other thing. So I've got my client experience, but let's say this table says it's only 50% credible. I need to find something else and blend those two things together with a weighted average, of course.
Does your company collect the data, or do you rely on others?
Good question. So my company collects the data on behalf of our clients. A lot of our clients have relationships with, the companies like Cigna and those types of health insurance carriers. They hold the data contractually for the client, and I just have to send an email and say, hey, give me all this stuff, and they pass it along to me. most of the time. Some of our clients have gotten real fancy in the last couple of years, and they have what's called a data warehouse, and they pay for an online platform service where you can pull all sorts of cool statistics and really geek out. Most of my clients aren't that lucky. Yeah.
Hey, this is just back to Social Security. I've heard that it's likely not going to continue or it's not sustainable. Do you have any kind of opinion on that? Or?
I don't know. This is being live streamed, so that's dicey, man. So I will skip. I will. Yeah. So Social Security is also tied to Medicare. I will comment on Medicare because that's more my wheelhouse. So if you're familiar with Medicare, also produced in the 1960s, produced, whatever, designed, created, implemented, that sort of thing. You've got Part A and Part B of Medicare. Part A pays for your hospital claims. Part B pays for your physician visits and some of your drugs. And it's been that way for a long time. But those two things are funded differently. Part B, you have to actually pay a premium when you retire into Medicare to maintain your eligibility and get the benefits out. Part A is funded by payroll taxes, like Social Security. So you pay, you get a wage and your employer takes all this taxes stuff off, whatever. Part of that is they're paying Medicare. Medicare Part A is projected to go insolvent by 2026. It's been projected to go insolvent by 2026 for a heck of a long time. And so they're going to have to either do two things between now and 2026, like legislatively. They have to either lower the benefits, which decreases the payout and maintains the solvency, or they have to increase taxes. I'm not going to make a statement about which one you might find more favorable, but that's the kind of idea. And Social Security, I think, is a further thing, but it is the same idea. At some point, if we don't keep supporting enough of a bigger cohort of future taxpayers to pay into the system, we're going to have to lower the benefits for people.
Is increasing the age of viable option?
Increasing Social Security age? Yes. So I don't know if you heard it. He was asking, is increasing the age a viable option? So the idea is, instead of being able to get your first Social Security benefit at 65, maybe you get it at 66. That is a way to help the insolvency. People don't generally like that because you've got people that are right on the cusp. And when you start doing stuff like that, they have to wait another year, and they might have been waiting to retire to do that. So you're messing with people's retirement plans, and it becomes a big political snafu. But that is one of the ways you could do it. Besides just increasing the benefit formula, you could change the age. Where do we go to? Oh my gosh. Great. Lovely. All right, we're probably going to do that. Any more questions? Did I answer yours okay?
Yeah, you got it.
Okay. I got it. Nice. What?
Just saying we need them to become the taxpayers for us.
Yeah. Yeah.
You guys.
Commercial break, become eligible taxpayers. You're doing Social Security is solid.
Thank you.
Okay. So one other thing that is talked a lot about in statistics is normalizing. A lot of times you hear this word when you're reading like a study, and they're like, oh, we're trying to look at this one thing, but there are 6 other confounding variables, so we had to strip out those other ones so we could focus on the thing we care about. The way this concept plays out in healthcare pricing work is as shown, and this is data that I totally made up. I wish my client data looked like this. It's not that easy. So the idea is, once again, we're looking at claims costs over time, and let's focus on the blue line. So we've got claims costs. They generally go up because of trend in healthcare. Trend in healthcare is related to 2 things that we often do get involved with decomposing for our clients. The first is, how much are my individual healthcare prices going up, which is usually not something our clients can control. That's hospitals and doctors and things like that charge more every year. The other is utilization. So even if my prices go up, but what if I use fewer services? That should keep my trend flat, right? This is kind of the thing that in healthcare we're combating every single year, is we're fighting against healthcare trend. That's been a long-standing thing and has outpaced inflation for decades. So after that sidebar, we've got this blue line, which is my clients' made-up healthcare claims. But what happened in January 2021, they decided to change their insurance plan. Instead of having a $500 deductible on an insurance plan, they have a $1,000 deductible on the insurance plan. What that means is now the person who goes to the doctor is going to be liable for twice as much before the plan starts to pay anything. That will lower my claims, which is why the blue line drops down, and you can't kind of see it, but it keeps going over here at this same old trend rate. Okay, so I have this one change I've made, but the problem is I'm looking over a 24-month period to project their costs, and I really can't rely on that other experience line because it's confounded. I've got an apple and an orange, basically. I've got one type of plan here and the other type of plan here. So what we do is we normalize for the change. I'm usually the one that told them what the change was worth, so I know that. So if it was worth, this is I think 5% or something. What I do when it's time to project their claims in the future, I go back to all their old experience on the blue line and I drop it all by 5%, which is what this orange line is. Now I've normalized the old experience to be an apple next to my other apple, and I can project all that stuff into the future. That sounds pretty mundane. One of the ways that this concept has played out very much in my life in the last year and a half is here. This is a real client, so you can see why it's not made up. It's not a straight pretty line. Anyone want to take a guess? That's his calendar year 2020 medical claims. Anyone want to take a guess what's going on? He got injured, okay. Not quite, and this is the whole group, so you can talk for a large, yeah.
Well, you can see it in March, which is when the pandemic started ticking us.
You know what, I should have explained. Yes, so the solid line is the data I have. The dotted line is the adjustment I made, and I should have clarified that.
In that case, you actually see it slow down during the first months of lockdown and pick up kind of dramatically, it looks like.
Yes, so he mentioned the pandemic. This is a direct adjustment we made for a client because of COVID. COVID, across most of the products I work with, which are medical, pharmacy, dental, and vision, for some reason, pharmacy seemed totally immune during 2020, but medical, dental, and vision especially, the bottom dropped out of claims March, April, May for almost every single one of my clients. And so when they were saying, hey, it's June 2020, hey Mason, what's my 2021 claims cost gonna look like? And I've got this massive dip that none of us saw coming. The question is, how do we adjust for that? So this dotted line, while I'm making it look nice and simple, this dotted line is the product of an epidemiological model that our company built based on national and regional COVID factors, hospital bed supply, infection rate projections, and all that fun stuff. We blended it all up in an Excel workbook and calibrated it to our clients' data. Because what we saw happen in 2020 is a couple of things, well, so many things, but let's just talk about the medical claims. Our clients had to pay for COVID tests, which actually increased their expense. When a member got infected with COVID, and a decent percentage, call it 1 to 5%, got infected with COVID and got sent to the hospital in the ICU. That is by far one of the most expensive places in the country to receive your health care. No one would ever choose to be in an ICU, but because of COVID, we had a lot more ICU treatment cases and inpatient cases in the healthcare system in 2020 than we had seen before. So testing costs increased my client's claims expense. Treatment in the ICU way increased my client's claims expense. And even net of that, my client's claims all went down March, April, May. And the reason is that on top of the two things that increased expense, the third thing is no one went to get health care for like 3 months. The whole country was like, I'm just gonna order from Amazon and do my Grubhub and chill in my house. And so if you weren't if you didn't get COVID, you pretty much weren't going to the doctor, which sounds like a good thing for my client's budget, except all my clients wanted to know, when's it gonna bounce back, number one. And number two, which is a question we don't often get from my clients, they're usually more concerned about like next year, and that's it. They're also concerned about, hey, all of the people that normally would have gotten screened for cancer and gotten screened for diabetes did not get screened in this time period. And does that mean I'm going to see an increasing prevalence of cancer, diabetes, and other chronic conditions because people just weren't getting screened? And the answer is still TBD, but it's a very good question. So in addition to like normal, regular normalizing for things we already measured, there was also this really big problem, and it still continues to this day. There's fuzziness in 2021 data because we had the Delta wave. Now we have vaccinations, which cost money, but also keep people from being infected, and all of our clients have different vax rates. So it's an ongoing problem. Any questions or thoughts about that before I skip over to the next piece? No? Cool. What's that? Okay, that is a bell curve. Perfect. This is like just classic statistics. Except I want to talk a little bit about how this bell curve was generated, because the way this bell curve is generated is a little bit of advanced statistics. So, most of the problems you start out with a probability or statistics class are of this form. And just go with me because I don't have a slide on this. Blah, 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 here's the situation. What's the chance that X is less than 1,000? And you are taking this situation and mapping it to a probability. That's like 90% of intro stats and probability is something's going on. What's the chance that it's below or above X? Your answer is a probability. And what we know about probability, it's always between 0 and 1. There's a 0% chance or a 100% chance, which is a for sure thing, and most of the time it's in the middle, okay? There are some parts of statistics that allow you to flip that mapping on its head. So instead of taking the thing and getting an answer from 0 to 1, I could actually randomly generate a thing between 0 and 1, and if I know the probability distribution, I can come up with an answer in the real world. And that's what we're doing here. Raise your hand if, have you guys covered log normal distributions? No. Have you covered normal distributions? Perfect. Log normal is like normal except squishier. So it's skewed, that's the technical terms. But we have made an assumption that one individual person, over the course of a year, their healthcare claims are log normally distributed. As soon as we make that assumption, there's all sorts of formulas about what that should do. I don't care about that, I just care about randomly generating from 0 to 1, and it produces for me a claims cost. This is, what we're doing here is called a Monte Carlo simulation. If I produce a random number once, and I've got a client with 1,000 people on the plan, I'm going to produce a random number from 0 to 1 randomly 1,000 times. And I add it up. That's a potential version of next year's budget. That's one trial. And then with the power of Excel and computers, blah, 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 I do that 20,000 times in like a minute or two. And now I've got 20,000 versions of next year, and that is what this bell curve is. It's 20,000 different reasonable versions of next year. But since I've got 20,000 things, I have the lovely law of large numbers on my side, and I just know if I just plot a little histogram, it's going to give me a bell curve. This is something we use with our clients all the time because healthcare claims are so volatile. They want to understand. Sometimes when I'm talking to people in human resources, they're just like, just give me the rates, man. I don't care how they were made, whatever sausage making happened, just give me the number, I'll use it. Sometimes we're talking to people in the finance department, and they're like, no, 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 no. I want to see behind the hood. I want to understand how conservative you've been in your assumptions, Mason, because I don't like to be conservative. A lot of people in finance, they want to make sure they're going to hit their budgets. This is a conversation about how likely you are to hit your budget, because if I know what this year is, and I've got 20,000 reasonable versions of what next year could be, now we can have a real conversation about confidence intervals and how likely you, yep, that's something you're going to cover apparently. That's great. January, cool, we're skipping ahead, but that's good stuff. So now we can use this image to say how likely you are to be at certain budget points. So this is like $42 million, and what this is saying is there's, and the red here is less than 1% chance. So if you're roughly at, oh, that's at 41.8 million, for this client, we're saying you could have a budget that's about $10 million higher than what we think. It's possible. It's less than 1% possible, but it's not zero. And a lot of times the way we flip the script with the finance folks is we say, would you like me to include extra cushion in my budget for next year? So let's say I thought your budget was $1 million. And I said, there's no conservatism in that. It's $1 million. It's my best estimate. And they say, now would you like to be 99% sure that your budget is good enough? Every finance folks argument, yes, yes, please. And then I say, cool, you just have to add 21% margin to that. And they're like, no, I'm not doing that. That's way, way, way too much. And now we've opened up the conversation a bit to what is a reasonable amount of margin that they want to take. So this is a advanced statistical method that we're using to create a really pretty picture that's recognizable from high school stats class to have a real-life business conversation about how much risk these companies want to take on when they're looking at healthcare stuff. That was not my last thing. I have one more quick thing. Any questions, thoughts, comments, or snide remarks about that?
This is like a little bit unrelated, but you were talking about the difference between resources and finance. Where do you fall in place if you're referencing like finance as a separate thing?
Yeah. I usually fall like right smack in the middle. A lot of times my clients, the main people we speak with, our clients all the time who are moving the strategic initiatives along, are in human resources. But because I'm the guy providing numbers to the human resources team, a lot of times the finance team will reach out to me directly. I actually end up having kind of two clients, if you will. One client who needs certain numbers. Among other things that I do, most of my clients have to put a reserve on their books, and I calculate that number for them and explain why it changes. And I usually do that with the finance team. The HR team is usually like, hey, what's my cost going to be next year? What if I change this? What would that save me? That sort of thing. Does that help?
Yeah, it does. Thank you.
So this is obviously not a perfect bell curve. Is there, I assume there's some significance to, the deformities in it, like that dip right here?
Yeah, because it's a Monte Carlo, so it's not a perfect bell curve. And that's because I could make it a perfect bell curve. I could just like use the formula and draw it out. But this is driven, as I said, by Monte Carlo simulations. So even if I had the exact same inputs and I run another 20,000 scenarios, it's going to have actually slightly different deformities. And that's kind of the point, is it's not perfect.
Well, let's say you do now, I don't know, 5 million. It would be much closer to perfect.
Excel would say, no thank you, and it would crash my computer. But if I had a computer that could do 5 million, it would be, you're right, the deformities would smooth out if that's what's going on. Yeah, that's a good question. Any other thoughts? This is my coolest picture, people. So get excited. Okay. One other thing, I will say, one other way we've actually used Monte Carlo simulations, and again, a lot of times my job is not to tell my client how I did the Monte Carlo simulation, just to tell them, hey, I gave you the answer you wanted. I've actually created fake census files with this method. So if I've got a client who wants to know what their new hire cohorts are going to look like demographically, and I have 4 years of census data, that tells me their average age, the average percentage that are male-female, and even the average pay. I can come up with a distribution, and again, as soon as I have a distribution, a lot of times I don't want to get a 0-1 answer, but I can randomly generate a 0-1 thing and get me a person. And so we've actually done projection work for clients where we've randomly simulated 1,500 people that we know are calibrated to look exactly like their average new hire, even though those 1,500 people are totally fake. So that's another way we've used this method, even though I don't usually go through the rigmarole of explaining to the client. Okay, a little bit of a fun last thing. This is a picture, 2013 to 2021 on the bottom, and some counts on the y-axis. If you saw this graph, the question is, what is the story you would tell of this picture right here? And speak up.
Average household income.
Say what? Oh no, sorry. I don't want you to guess what this is. I'll tell you what it is. I want you to tell me if this is all you saw. What's the tagline? What's the headline for this picture? What is it telling you is happening? I haven't told you what it is. So it's a significant drop, which he's right. Look at that. That's 2019 to 2020. So a significant drop. Okay, that's what's happening here. Same question, different picture. What's happening here? Daily squat. Okay. What's happening here? A little bit. Yeah. Here's the fun part. You might have already guessed this. All three of these pictures are the exact same data. All I did was zoom in and out my y-axis a bit, which is ludicrous because this is like, oh my gosh, the bottom fell out. This is a nothing burger. And this over here, by the way, the real answer is it went down 3% and then 0.4%. That's not really a statistics lesson per se, but it's mostly about if you're using data and helping anyone visualize data, we have to be responsible. We have to be stewards of that information. This is obviously not the story, and this isn't really the story either. Neither of these first two graphs is fair. There's no formula that I'm aware of, you guys tell me if there is, there's no formula I'm aware of to tell you where to set your y-axis settings in Excel. You get to pick that. Someone literally a couple days ago posted a journal article locally about this is enrollment in a public school system. And they were like, oh my gosh, it's going way. This was the picture they published online. And I kind of scratched my head because they were gracious enough to include the y-axis in their picture. And I was thinking enough to pull out my calculator and figure out what they'd done. So then I typed it up and made this picture and this picture. All three are right. The question is, if you were in charge of this, which story would you tell? So we have to be a little careful when we see things or when we're working with data sets and we're producing visuals, that we can tell any story we want to sometimes if we're willing to fudge a little bit. So that, with 5-ish minutes left, is my entire spiel. I would love to take questions about my job or whatever else up here you were curious about in the remaining time we have. But thank you for listening intently.
You guys know about that last slide. So how come you said that picture is not representative, or like there's no accurate formula if that's showing like the jury will actually be there that that's like the size of it is the same. So how come that's not like an accurate picture?
Yeah, because what I meant by not accurate is this visual, if you're not paying attention to the numbers on the y-axis, which, let's face it, the vast majority of the public won't get out their calculator and check you on that. So if you're putting this visual out there, it makes it look like something absolutely crazy has happened. What I'm telling you is, if you look at the actual numbers behind this data, this is a 3% drop. But because they chose to zoom in the y-axis to only be from, like, have a 2,000 count difference, it looks like a 75% drop. So I said, cool, I can play that game. I'm going to zoom out so the bottom is 0, goes all the way up to 60, and now you can't even see that 3% drop. I would say that's also inaccurate, because this feels like nothing has happened, like 0% change. I would say the truth is probably somewhere in between, and I chose to put this here just as an example to say there's something going on, but it's not like a calamitous zombie apocalypse situation. That make sense? Yeah, and my point was there's no formula that I'm aware of that tells you where to put your y-axis settings in Excel. So you could produce this picture and get a lot of people freaked out. You could produce this picture and sell 0 newspapers. Or you can produce this picture and try to focus on what's really happening. That's a choice.
So for like data visualization, like for your clients, what kind of, do you try to aim for like the middle ground to make it like as understandable as possible?
Yes. Yeah, so I do try to aim for the middle ground. There are some times when we will zoom in onto one particular issue, so to speak. But when I do that, I'm very careful to caveat that we have done that. You know, objects in the graph may appear larger than they are, type of thing. Any other questions? Well, thank you. Thanks for your time.
Can we get one more big round of applause? Thank you. Also, please make sure you have signed in so that we can get an